So this one includes the reciprocal apparatus, but really not as functional as we have the wet specimen. We might try doing that one. You can see the same thing happening here as well. Okay? Flexion of the stifle, flexion of the hock. Okay? But along with those features, we also have some other ligaments in this one. Okay? So what structure is going to be this one? That's your superficial digital flexor. In this one, we still have some part of the gastrocnemius left. Okay? Then this is some leftover of the deep digital flexor muscles, usually originate on the caudal surface of the tibia. Your lateral, medial, as well as caudal tibial muscle, they are going to be like this. Okay, then this is your peroneus tertius. This is fibula. Okay, then we have part of the cranial tibial left here. Okay, so that is peroneus tertius, cranial tibial, proximal extensor retinaculum. Okay. Yeah, this one here, that's a proximal extensor retinaculum holding both of them in place. Then we have middle one running this way, and then we have distal one. So how many extensor retinacula are here? We have 1, 2, and 3. Because of the way the extensors of the digit are passing over the flexor surface of the hock, they need more than one. There could be just one here may have worked, but it would then probably cause more friction with the joint. And so we have one here, and one here. Okay. Tibial tuberosity with crest of the tibia, insertion of all the patellar ligaments. Okay. Medial patellar ligament, middle patellar ligament, and the lateral patellar ligament. Okay. Extensor fossa, origin of the long digital extensor as well as peroneus tertius. And remember, this is fibula, nothing else but the bone fibula. Okay. Okay, let's turn it to the medial side. The medial side here. So that's in the medial side here. That is the common tendon of the DDF formed by lateral digital flexor and caudal tibial muscle. Remember what we saw on the other specimen. The medial digital flexor does not join the tendon above the hock. It joins that tendon below the hock, and this is the tendon which we were talking about. I think somehow it has came off its groove where it was running through. Okay? It probably has to go from this passage here where the probe is now. Okay? It has to come down here and then join the deep digital flexor tendon. Okay? Okay, now what else we see here? The most important structure is this one here, that is the accessory or check ligament of the DDF. Fortunately, this horse they prepared had the ligament, or it still has a ligament. Okay, so we have the check ligament or accessory ligament of the deep digital flexor. Now, how can we differentiate that from the medial digital flexor tendon? This is just round cord-like structure, while this one is more flat. It is extending from the caudal part of the joint capsule. What joint capsule is that? That is joint capsule of the hock. In the forelimb, that ligament is extension of the carpus joint capsule, which is palmar carpal ligament. In the hind limb, that is extension of the hock joint capsule, but we don't really call it tarsal ligament also. Okay, so that is simply your extension of the joint capsule going to the deep digital flexor. Okay, what structure is this? Interosseous muscle splitting into two divisions. First of all, getting attached to the proximal sesamoid bones, and after that, continuing further on the dorsal aspect as the lateral and medial extensor slips of the interosseous muscle, joining the long digital extensor in the hind limb and common digital extensor in the forelimb. Okay, so what structures are those? This is your extensor slip of the interosseous muscle, extensor slip of the interosseous muscle on the other side. Well, this is your long digital extensor tendon. The long digital extensor tendon, as it runs further down, it also receives the lateral digital extensor tendon. That's the lateral digital extensor, which runs through this groove or over the lateral malleolus, and then it continues further to join the long digital extensor. What we do sometimes, you find out that muscle in that groove, you expose the tendon and you transect the tendon. To get rid of like string halt, like jerky flexions of the hind limb, maybe we could it is observed that cutting the lateral digital extensor would solve the problem. And as we don't need the lateral digit extensor much because there is no lateral digit, so we can cut this tendon without having any adverse effect on the organ function of the distal joints. Okay, can you identify the cunian tendon on this specimen? Okay. The medial division, large trochlea or large ridge of the trochlea, medial side, that is medial division of the cranial tibial, that is the cunian tendon. Okay, can we cut the cunian tendon? Okay, can we cut that one, or in certain situation can we cut the tendon? Yes, because the cranial tibial, because of the reciprocal apparatus, the cranial tibial has almost become non-functional. Okay, and that's why we can afford to cut the tendon of the insertion of the cranial tibial. Okay, now after you cut the cunian tendon, there is still one more ligament which is attached to the proximal end of the metatarsal bone. So how many divisions we have for the cranial tibial? We have two divisions: the dorsal division, which is attached to the metatarsal bone, and the medial division, which is attached to the tarsal bones and metatarsal bone. So we can afford to cut this one while the other one is still present.
Is it a part of the stay apparatus?
Oh, not really.
No.
So the reciprocal apparatus is part of the stay apparatus, and so that's why the cranial tibial becomes almost non-significant. There is other thing which is observed, like when you have section of the peroneus tertius, the cranial tibial now try to compensate that flexion of the hog, but again that muscle alone is not capable of flexing the hog of the horse. So what do you usually get? We get jerky flexions of the hog in that situation. Extension is not affected. Animal can still bear weight, but when animal takes a step forward, it's going to be like flexions would be in that jerky manner or spastic manner also. Okay, now if you see a groove running right here on the cannon bone, which is on the medial side, that actually for the passage of the vein, and the groove on the lateral side, which is deep, okay, that is the blood vessel there, that is an artery. What artery would be that? Dorsal metatarsal artery 3, okay, which will then go to the plantar surface. Okay, splint bone, cannon bone, deep digital flexor, accessory ligament of the deep digital flexor, superficial digital flexor, its first insertion on the calcanean bone, and then further continuing its insertion on the middle phalanx. But where on the middle phalanx? Right at the proximal end of the middle phalanx. And so some fibers are also attached